Okay, good afternoon, everybody. Thank you for joining. My name is Ben Hague, and today me and my colleague Pete Berry are going to talk through the impact of cover crops on carbon emissions. So this webinar is part of a Horizon Europe project called Climate Farm Demo. Within that project, myself and Pete are the thematic leaders for the crop management thematic area, and we work for a UK organisation called ADAS, who provide agricultural research and on-farm consultancy. So firstly, just a few housekeeping rules. This webinar will be recorded. During the session, we're going to have a Q&A session in about 30 minutes, but during the bulk of the presentation, the cameras and microphones have automatically been turned off. If you want to ask any questions, we can address these in the Q&A session, but feel free to put these in the chat throughout the presentation. Otherwise, when we come to the Q&A, you'll be able to raise your hand and then you'll be able to unmute yourself and ask a question using your microphone. So firstly, just to run through the agenda for today, I'm going to give a summary of the greenhouse gas emissions associated with crop production, and then give quite a high-level overview of cover crop management. I'll then pass over to my colleague Pete Berry, who will go through the impact of cover crops on greenhouse gas emissions. We'll then end with a 15-minute Q&A session, and you'll have a chance to answer your questions to us. So firstly, we're going to start off with a couple polls just to understand the audience. So hopefully you should see the poll appear on your screen. If you just select the most relevant answer to what sector do you work in, so farmer, agronomist, researcher, if you work in industry, in policy or other. And I can see some of the votes are starting to come in. Got 17 responses so far, so we'll just give that a couple minutes. So at the moment we're up to about 30 responses. About 11% are farmers and agronomists respectively. We've got 17% researchers, about a quarter from industry, and then interestingly about 30 or up to 40% from other. So if you're willing, if anyone wants to expand on that in the chat, then please feel free. We'll just move on to the second poll. This is just to understand why people are motivated to know more about cover crops. So what do you think are the main reasons for growing cover crops? In this poll, you can select multiple answers, so feel free to select the responses that you feel most closely align with what your thoughts are, whether that be improving water quality and reducing soil loss, improving soil fertility, improving soil structure, to control weed and pest control, or to reduce carbon emissions, or other. And again, please feel free to expand on that in the chat. So the responses are starting to come in, got 20 so far. I'll just give that a couple moments. So we're up to about 30 responses. The most common answer so far is to improve water quality and reduce soil loss, closely followed by improve soil fertility and soil structure, and then 10% down at controlling weed and pests, and then quite a small proportion to reduce carbon emissions. So hopefully by the end of this presentation we know more about the impact of cover crops on carbon emissions, but interesting to know that improving water quality is the main motivation for most of the audience. So firstly, a definition of to make sure we're all on the same page for the remainder of this webinar. Today we'll be talking about carbon emissions, and so these are expressed as the equivalent warming effect of carbon dioxide, nitrous oxide and methane, and these are described as the carbon dioxide equivalent warming effect, or the CO2e. We may interchange between greenhouse gas emissions, carbon emissions and carbon footprint, which all relate to the same thing. And then if you're focusing on crop production, the main drivers of greenhouse gas emissions are nitrous oxide and to a lesser extent carbon dioxide. So we know that nitrous oxide has a warming impact of about 265 times more than carbon dioxide. So reducing our nitrous oxide emissions is the real driver to reduce carbon emissions associated with crop production. Moving on to sort of the range of carbon footprints we see for different crop types. So this is data taken from our Yen0 network, which is a carbon calculator we developed at ADAS for a network of farms. On the y-axis, we've got the carbon footprint expressed per hectare. So that's the kilograms of CO2 equivalent per hectare. And then you can see across the range of arable crops, the carbon footprint ranges from about 750 kilograms of CO2 equivalent per hectare up to about 3,000 on the far right-hand side for maize grain. And we can sort of split these emissions into different groups based on the nitrogen requirement for different crop types. So on the far left-hand side, we have our pulse crops, which fix nitrogen, so we don't need to apply any nitrogen to these crops. In the UK, the pulse crops we grow are field beans and combining peas mostly, and these have a carbon footprint around sort of 750 kilograms of CO2 equivalent per hectare. In the middle group, we have what we could classify as low nitrogen input crops. These are generally non-wheat cereal crops, so barley, rye, and oats. And then on the far right-hand side, we have crops which have quite a high nitrogen requirement, generally about 2,500 kilograms of CO2 equivalent per hectare, and this includes winter wheat and winter oilseed rape. We can then draw in closer onto what makes up the carbon footprint for a typical winter wheat feed crop. So here we've separated the sources of emissions from the different sort of characteristics of crop production. So the two big ticket items on here are the nitrous oxide emissions associated with the application of nitrogen fertiliser and the greenhouse gas emissions associated with the manufacture of nitrogen fertiliser. And together these two blue portions of the pie chart here make up about half the carbon footprint for a typical wheat crop. So this shows us that reducing the amount of nitrogen that we apply to crops is really the big lever to reduce the overall carbon footprint for a winter wheat crop. To a lesser extent, we have the fuel use in operations. So this is the diesel used to carry out field operations like spraying or combining. And then we also have the nitrous oxide emissions from the decomposition of crop residues after the crop is harvested. And together these make up about 30% of the carbon footprint for a typical winter wheat crop. And then some of the smaller proportion of carbon footprint is the nitrous oxide emissions associated with the application of manure, the production of the seed, agrochemicals, so your pesticide applications, and then the manufacture of non-nitrogen fertiliser. So to move on to cover crops, this is just a really high level overview of how we manage cover crops from a UK perspective and the definition of cover crops so that we're all on the same page. So here we've defined a cover crop as a plant grown primarily to protect and improve the soil rather than to be harvested for food or profit. These are usually planted in late summer or early autumn and destroyed in the winter or early spring. So this is different to a catch crop, for example. Here we're just focusing on cover crops. The method of destruction can vary, so you can mechanically destroy a cover crop, which could include a plough, for example, and you could spray off with glyphosate, or there's an option to graze it with livestock as well. Typically, we don't apply any inputs to cover crops, so no fertiliser, and there's a wide range of cover crop species which could be grown, which can be broadly categorised as either cereals, brassicas, legumes, or others such as buckwheat and phacelia. This is just a visual example of the different cover crops we can grow. So there's a wide range of cover crop options which can be used for different purposes. So you might elect to choose a clover crop to fix nitrogen, to provide more nitrogen to the following crop. Cereal crops such as rye typically have quite rapid growth and early cover to reduce soil erosion, but also to create deep pores in the soil due to deep rooting. Brassicas have quite rapid soil cover, so they can take up nutrients quite early on to reduce nitrate leaching. But most commonly, people like to have a mixture of all three to combine the benefits and maximise the success. So I'll now hand over to my colleague Pete Berry, who will talk you through the carbon dioxide emissions associated with cover crops. Thanks, Pete.
Thank you, Ben, for giving that very useful overview of cover crops and greenhouse gas emissions. So now we're going to focus on what the effect of cover crops are on greenhouse gas emissions and carbon emissions. And I want to start by doing a poll where you consider what might be the best way in which cover crops affect greenhouse gas emissions, or even if they affect them at all. So do you think that they could reduce greenhouse gas emissions through reducing fuel use associated with field operations, or reducing fertiliser use, or reducing carbon emissions from the soil, such as nitrous oxide, or perhaps you think they might be able to increase the yield, and that thereby reducing the amount of carbon emitted per tonne of yield produced? Is there another method that you think they might reduce carbon emissions by? And if so, could you put that into the chat? Or perhaps you think there's no reduction at all. So if you could sort of do that poll and see what you think. So we can see the results coming in now, and we've got the leading contender at the moment is reducing fertiliser use, along with reducing carbon emissions from the soil, and much smaller amounts for reducing fuel use and increasing crop yield per kilogram of carbon emitted. Okay, that's really useful. So the majority of you are thinking it's going to reduce fertiliser use, and that is the main route for reducing carbon emissions. Okay, thank you. So let's start then by considering what are the greenhouse gas emission costs associated with cover crops. So we can summarize these in terms of the seeds planted. There's an embedded carbon emission associated with the seeds that are planted. We've got the fuel to establish the cover crops. We've got the destruction of the cover crops, either mechanically or by grazing or by herbicides. And there's also the possibility of the following crop yielding less and thereby causing greater carbon emissions per tonne of crop produced. What are the benefits, potential benefits? There could be fewer greenhouse gas emissions directly from the soil. You also get indirect greenhouse gas emissions associated with any nitrate leaching. A reduction in fertiliser requirement for the following crop, and the possibility of the following crop yielding more. So let's look at some numbers. We look at the greenhouse gas costs for each of the factors associated with growing a cover crop. So we're measuring these in terms of kilograms of CO2 equivalent per hectare, as Ben described earlier. In terms of a seed, they could be ranging from as little as 2 kilograms of CO2 per hectare, for example, for a low rate of mustard seed used, to as much as 50 kilograms of CO2 per hectare for a cover crop which is cereals or perhaps peas or beans, which have a greater quantity of seed used. The fuel for planting the seeds could also vary a lot. It could be as simple as broadcasting the seed, which would have a relatively small greenhouse gas cost, to, for example, direct drilling the seed and rolling it, which would have a greater cost of about 51 kilograms of CO2 per hectare. Mechanical destruction, again, a big range. It could be as simple as rolling the crop on a frost, an example here in the photograph here where we're rolling a cover crop in January after a frost to help destroy it, or it could be something which requires a lot more energy, such as cultivating and chopping up the cover crop or using discs, and there you're looking at a greenhouse gas emission amount of over 60 kilograms of CO2 per hectare. The use of a herbicide such as glyphosate to destroy it is a much lower carbon cost, and that includes the sort of embedded emissions in the herbicide itself. Livestock grazing is a difficult one to quantify because there's so many sort of variables within this, especially the duration of grazing. But that should not be underestimated, what the level of greenhouse gas emissions associated with that could be, especially using ruminant animals to graze it. If we look now at the benefits, now one of the most important potential benefits of cover crops is to reduce the risk of nitrate leaching. So I'm next going to show you a couple of examples of experiments where we've measured nitrate leaching losses under different cover crop systems. So what we've got here is on the y-axis, we've measured the nitrate leaching losses over winter in terms of kilograms of nitrate N per hectare. And we've done that for a range of different crops. These are all in the same field experiment. So we've got stubble, which that doesn't have a cover crop and it's not being cultivated. We have a treatment where the stubble was cultivated. We have oats with mustard established, and these are all established in late August. We have radish with oats, and we have a premium mix of cover crop with a multiple range of species used. And for each of these porous pots we used to measure the nitrate leaching losses, you can see that the greatest leaching losses are for the stubble, where we had very little crop cover of less than 5%. And there we're seeing nitrate N losses of 90 kilograms of N per hectare. So that is a lot. And this was a soil type which was very porous. It's a shallow soil type, which is quite prone to leaching losses. Interestingly, the treatment where we cultivated the stubble actually created a modest crop cover of 35% because it stimulated some weed growth. So that's what caused that 35% crop cover, and that reduced the amount of nitrate leaching down to 60 kilograms of nitrate N per hectare. Where we've used a cover crop, oats and mustard, we've got a bigger cover of 60%, and that's reduced the nitrate leaching again down to about 25 kilograms of N per hectare. And where we've got the largest crop covers of 80%, 90%, there we're reducing the nitrate losses to 10 kilos or less per hectare. So you can see the cover crop in this situation has caused, a big reduction in the nitrate leaching from 90 down to as little as less than 10 kilos of N per hectare. I'm going to show you another example in the next slide. So this is a different experiment, different year, different site. We've done something slightly different here to illustrate the effects of the cover crops. What we've got is on the y-axis, we've got the amount of nitrogen in either the soil in this first part of the column or in the crop itself in green, and the amount of nitrate N leached in blue. And this is all measured right at the very start of spring after winter. So this is just before the cover crop's going to be destroyed. We've got a stubble with no cover crop. We've got a mix one, which is 80% oil radish and 20% phacelia. And mix two is 45% buckwheat and 45% Japanese oats and 10% phacelia. And what you can see is that where we've got no cover crop, just a stubble, at the start of spring, we've got about between 40 and 50 kilograms of N per hectare in the soil as mineral N. We've got another 20 kilos in the sort of weed growth, which happened on the stubble and we've got over 20 kilos of N per hectare lost as nitrate leaching. Where we have the cover crop, we have a similar pattern. We've got less nitrogen in the soil because it's been taken up into the cover crop itself, and we've got an amount of nitrogen in the cover crop of 70 to 80 kilograms of N per hectare there, and that's protected the nitrogen against nitrate leaching, where we've got less than 10 kilos of N per hectare leached. So two good examples really of how cover crops can reduce the amount of nitrate leaching. So if we sum up the impact of cover crops on nitrate leaching and fertiliser requirement, we found that from our own experiments at ADAS and also from looking at the published literature, a well-established cover crop would typically take up about 45 kilograms of N per hectare if it was a cereal cover crop. If it was a legume or a brassica, then we could be looking at as much as 90 kilograms of N per hectare taken up. Critical to this is early establishment of cover crops. We're really looking at establishing before early September to be able to take up these levels of nitrogen. Anything later than mid-September, at least in the UK, significantly reduces the amount of nitrogen uptake and the potential benefits of the cover crop. Measurements that we've done of nitrate leaching can range from reductions in nitrate leaching of between 10 to 80 kilograms of N per hectare. So you can see there's a big range, and that's partly down to ranges in soil type, the amount of nitrate leaching that that soil is experiencing, the amount of overwinter rainfall at that site. So that explains why we have such a big range there. In the UK, the guidance is that for a well-established cover crop, the amount of nitrogen fertiliser to be applied to the following crop would be reduced by about 30 kilograms of N per hectare. This clearly requires the nitrogen which has been taken up by the cover crop to be mineralised and be available for the following crop. And that is an area of uncertainty which is certainly still an issue potentially, because there's all sorts of factors which affect the availability of that nitrogen to the following crop. But one of the most important factors which you can do to maximize the chance of that nitrogen being available is to make sure that the cover crop is destroyed quite early. So by quite early, we mean destroying it in January or February. And we actually found that using a herbicide, glyphosate, to destroy the crop was more effective at enabling the release of the nitrogen from the cover crop for the crop following it. So if we work out the greenhouse gas benefit of reducing the fertiliser by 30 kilograms of N per hectare, then it amounts to 213 to 226 kilograms of CO2 per hectare, depending on what nitrogen fertiliser product is used. So if we sum up all of this, then the greenhouse gas costs for establishing and destroying a cover crop could vary enormously depending on how you do it. It could be anything from 20 kilograms of CO2 per hectare up to over 160. If you were, for example, simply broadcasting mustard seed, and then you were using, for example, glyphosate herbicide to destroy it, then you'd be the lower end of a range. If you were using a seed with larger quantities is required, such as peas or beans in the cover crop, and you're mechanically destroying it, for example, by disking it or chopping it up, then you're looking at over 160 kilograms of CO2 per hectare. The benefits in terms of greenhouse gas emissions are largely dependent on whether you can reduce the nitrogen fertiliser to the following crop, and they could exceed the sort of costs in greenhouse gas emission terms. This is assuming that you're reducing the nitrogen fertiliser by about 30 kilograms of N per hectare. Of course, there are other possible benefits of cover crops, such as to soil structure, reduce risk of soil erosion, weed and pest control, biodiversity and habitat provision, and it's also a grazing opportunity over winter for livestock. And we also need to recognise that the benefits might not be sort of shown in the first year. They might be long-term and occur in the years after the following crop. But we also need to recognise that there are some disbenefit potential, such as through volunteer plants in the following crops, such as the limitations that cover crops can make on the crops rotation. For example, if you grew a brassica cover crop, then that could limit you growing brassica crops later on. So it's not all benefits. There are some disbenefit potential as well. In terms of the yield of the following crop, that I think we need to recognise can be variable. In our experiments, we've seen both yield reductions following cover crops and yield increases. We've seen more yield increases than yield reductions, but where we have seen a yield reduction following a cover crop, it's been largely due to late destruction of a cover crop, often using mechanical destruction methods, and wet conditions around the time of destruction of a cover crop and establishment of the following crop, which has really reduced the establishment of the following crop. And we've sort of encountered issues such as slug pressure damaging the establishment. So it's not a given that cover crops will result in higher yields. Okay, I want to finish by asking you to conduct another poll and to consider what aspects of cover crops you would like to focus on in the future. Is it impact of yield on the following crop? Is it impact on soil quality? Is it integrating livestock grazing into a cover crop system? Or if it's something else, it'd be really useful if you could put that into the chat so we can capture that information. And if you could sort of rank those in terms of the highest and most interesting first, that would be excellent, and we can then get a priority order. Okay, so the results coming in, seeing pretty equal really for impact of yield of the following crop and impact on soil quality. Integrating livestock grazing is coming out a bit further down. It's like they're all quite important, but yeah, that's really useful. Thank you. That will help us get the right topic that we do next. Okay. Thank you for carrying out that poll. Next, we have a session of questions and answers. So if you would like to put any questions into the chat, or if you would like to say your question, then please just raise your hand and we can unmute your microphone and you can say the question verbally. I'm just going to go down to the questions now and just see what's been coming in.
Got one from Sean in the chat, Pete. So have we looked at the difference between urea and ammonium nitrate fertiliser to make the carbon reductions, given urea has a higher risk of nitrous oxide emissions?
Yeah, I mean, with that range of greenhouse gas emissions associated with the reduction in nitrogen fertiliser was the range for urea and ammonium nitrate, and there's not that much to choose between them. They sort of have similar carbon footprints, but for different reasons. I mean, what I would say is that I think if you're using urea, it's useful to use a urease inhibitor to minimize ammonia losses, because that results in indirect greenhouse gas emissions as well. If you're using ammonium nitrate, using a nitrification inhibitor will greatly reduce the nitrous oxide emissions that come from ammonium nitrate. So you can do quite a lot really to reduce the carbon emissions from both of those nitrogen products.
Thanks, Pete. Got a question from Megan. Is there a concern that if glyphosate gets banned, that the reduction methods of cover crops will result in a larger impact on carbon footprints?
Yeah, I think there's no doubt that sort of the management of cover crops will become more of a challenge if glyphosate was not available. There's no doubt about that. You know, there would no doubt be sort of efforts to look for alternative herbicide methods. There's not any obvious ones which are as effective at glyphosate at the moment. But yeah, it could be an issue in the future. I can see another question, which methods we use to measure nitrate leachate in the cover crops? Well, we use the porous pot method, which involves sort of digging a hole down to about a meter, and we sort of install a porous pot, which then collects the water which drains beyond the rooting zone of a crop, and we sample that regularly to measure the nitrate in that water solution. And that's done over a period of time over the winter. So it's a pretty intensive job. You know, it's not something you can sort of do, you know, on many treatments. You have to sort of select the treatments that you do focus that on. Have you been able to compare the effects of winter cover crops on heavier soil types? Yes, we have. And that's where we've had the biggest challenges with establishing the following crop. And the example I gave you of one or two of the yield losses we've seen following cover crops have been on heavy soil types where the crop has been destroyed late, the cover crop's been destroyed quite late, and then it's been a challenge to establish the next one because you've got lots of cover crop residues and wet conditions in heavy soil, making it difficult to establish the following crops. So I think it is more of a challenge in heavier soil types, and I think it's especially important there to have a decent long window between the destruction of a cover crop and the establishment of the following crop. This question is, do we have data on how cover crops can help reduce the presence of raygrass in crops? That's something I don't know the answer to, and I'm going to go back to our colleagues at a later date and come back to you with that one, if that's okay. Next one is, have you considered the effect of destruction methods on other soil organisms that could be beneficial to the next cropping season? I don't think we have, no. But again, we will go back to our colleagues and see if there's any sort of information on that. And what we plan to do with these questions, which we're not able to answer currently, is we'll circulate sort of our best answers to you after the webinar so that you can get some sort of feedback on those questions, okay? Did you get as far as looking at how much soil organic matter different cover crops leave behind? We have done that, yes. I mean, it does take it takes many years to build up the soil organic matter content, and you need to sort of have some pretty big increases in organic matter to start shifting the soil organic matter. We have done that though, and over many years, we have been seeing an increase in the soil organic matter, but it does take a long time to start to shift that. Again, I think in the response to the questions document we send round, we'll give you a bit more chapter and verse on that from what experiments we've been doing on that topic. Do the top carbon calculators, such as Cool Farm Tool, AgriCalc, take into account the different species, cultivation, establishment length? That's a good question. I should think it's some and some, that some do and some don't. But again, let us come back to you with an answer to that question, because it's an important one, isn't it? You know, we've shown that there's a big range in the carbon cost of establishing and destroying cover crops, which could impact on the overall carbon footprint of your crop and the farm. Yeah, it will be interesting to know whether they do take into account that level of detail. I think it's probably worth recognizing, and I meant to say this at the time, the sort of relative amounts of carbon emissions associated with cover crops to normal cash crops. So Ben showed that for normal cash crops, the carbon footprint ranged from as little as 700 kilograms of CO2 per hectare for beans or peas to about 1,500 to 2,000 kilograms of CO2 for low N input cereals to 2,500 or more for high N input cereals. For the cover crops here, we're looking at greenhouse gas emission costs of establishment and destruction of between 20 and 168 kilograms of CO2 per hectare. So that's the context that we should recognise here for the cost of the cover cropping in terms of carbon. David's put in a question there. If the alternative for the cows was to be housed on farm and fed silage, is the effect of grazing actually positive? Well, that's a good question. I mean, yes, we'd need to sort of compare what the alternative system was for estimating the impact of grazing. The grazing is a really interesting topic, actually. I mean, often it's sort of sheep, isn't it, used to graze over winter. But if it's livestock, you want to look at the alternative. Interestingly, when we've measured the nitrate leaching of cover crops after grazing, and if it's grazed right to the ground level and there's very little crop cover left, and if the grazing occurs quite early on in the winter, sort of December time, then we've actually seen quite a lot of nitrate leaching, which occurs in that sort of scenario, because basically the sheep or the livestock which are used are converting all the crop growth into urine and dung, which is highly leachable, and it does actually leach. So there's potentially a disbenefit in terms of the impact on nitrate leaching if you grazed your cover crop, especially if you graze it early. So our advice is that if you are grazing and you want to minimize those nitrate leaching losses, then you should graze as late as possible in winter, and also try to leave a bit of crop cover, at least 20% crop cover, to minimize the risk of nitrate leaching. Ben, any of those questions you want to add anything to which I've overlooked?
No, I think you've covered it all comprehensively. Thanks, Pete.
Okay, well we'll make a note of those questions. I can see just one extra one's come in. Water management. How can you compare water consumption of a cover crop to multiple tillage of stubble with regard to the following crop? Yeah, we'd have to think about that. I mean, we do in ADAS, we do have a model for estimating water use of crops, which I think we could apply to cover crops. It should be possible to do that, but I don't know of any work which has actually worked out the water use of cover crops compared with sort of alternative controls, such as no cover crop. Let us come back to you in our response document on that one. Okay. If you have any other questions which come to you sort of after the end of this webinar, then don't hesitate to email either Ben or myself using those email addresses there. We're very interested to sort of engage with you and try our best to answer your questions. Okay, I think perhaps we'll draw it to a close there now, if that's okay. Thank you, Ben, and thank you, Bree, for presenting and organising all this. And thank you for your questions. They're really stimulating, and hopefully they're useful for everybody.
Thanks, Pete. We will circulate recording as well, so keep your eyes out for that if you'd like to catch up.
Thank you all. Have a good rest of the day.
Thank you.
Bye bye.